All right, so this video is going to be a little bit different in that I'm going to do some live coding for you to talk about algorithm efficiency. We've gotten to the point now where we can build some very complex programs, particularly when we utilize nested loops. And that can lead to a problem. Complicated programs can be slow programs. And so we don't want our program to be slow. We want it to be quick. We don't want it to do more work than it needs to. We want it to be lazy. It's like us. We don't want to do extra work. We don't want our program and our CPU to be doing extra work. So we're going to talk about how to get our programs to work a little bit more efficiently, how to look through some code and see what we can do to do what's called refactor to make our code more efficient. Let's take a look at it. So here I have some code, and I'm going to walk you through it. So the main idea of this code is to find some duplicate characters within a string. I have these first few lines here that essentially set up our scenario. It asks, oops, I need to spell that right. It asks the user for a string, and then the user inputs it. It stores it in an input variable. We check, we're going to have a Boolean that checks if there are duplicate characters within that string. And we have this little loop counter, which we're going to use to visualize and see how many times a loop is executed. So I have written a first run of how to solve this problem with 2 loops, nested for loops, and 3 if statements within here. And let's go ahead and let's just see how this runs. So we ask for a string that we'd like to check. I'll go ahead and type hello. We know that there's repeat characters in there. And so this should tell us that there are repeats. And when we hit enter, yes, it says, hey, error, duplicates found. And it also tells us our loop counter is 11. Which happens in this block of code down at the bottom, which is going to be consistent. We're not going to change any of this code. This will simply print out for us what's going to happen. And if there are no duplicates, it'll print out no duplicates. Otherwise, it'll tell us that there's an error and that duplicates were found. But this ugly mess right here, this is what we need to make more efficient. So I'm going to go ahead and copy this code. And I'm going to put a new copy of it down here so that we can watch the iteration and you'll have access to this once we're done. So I have the copy of it. I'm going to turn off this first copy since we know it works. And let's take a look here. So we have an outer loop that goes through the entire length of our string. Okay? And then it has an inner loop that also goes through the entire length of the string. So it's going HELLO, and this one is also going for each character HELLO. Think back to our previous video on nested loops where we printed out 1 through 10 vertically and 1 through 10 horizontally each time. That's what's going on here. We're checking that our inner does not equal our outer number. So we don't want to check that the same number or the same position within the string equals the same thing. Because, right, H equals H. If I'm checking each position each time, H equals H. That's going to cause a problem every single time. We also want to check that we haven't already found a duplicate. Okay, that's good. We want to find that we're then going to store our outer string, so our first character, and then we're going to store our second character. So we grab those at outer and outer plus 1 and inner plus 1, and we store those into 2 separate strings. We're going to count that we've gone through this loop, and then we're going to check, does our outer equal our inner? And if it does, that means that we found 2 characters, L and L, right? That means that we are going to mark it as false. Okay, now that we've walked through this, let's think about how we can get a little bit more efficient. Well, our first thing is we don't need to actually check every character every time. So maybe instead of going from this character and moving over, we can in fact just keep checking from the character we're already at. Let me demonstrate this. So if I have the string HELLO, and remember that each of these has its own index position. So it goes from 0, 1, 2, 3, and 4. In our current iteration of this algorithm, no pun intended there, our outer goes each character from 0 to 1 to 2 to 3 to 4. And our inner also goes, for each one of our outers, it's going to go 0, 1, 2, 3, and 4. Just for 0. And then it's going to do that again. And then it's going to do that again. All the way from the beginning. But what if we do this instead? What if we say, once our outer is here, we check our inner, but then our outer moves to a new position. So our outer started here, but now our outer is at position 1. Instead of going back to check the H against the E, we've already checked that pair in our first run through. We can now instead check this pair. And we could instead, then we move on to this one, and then we can move on to this one. You're starting to get the picture, and we're going to make that even better. I'm sure some of you already see this. So we can now say, instead of saying inner equals 0, we're going to have inner start where outer is and move up from there. So our first loop count was 11. Let's see what difference just this one change makes. How many less times loop counter runs from this one change? Checks the same word. 8. We knocked off 3 of these. Okay. Well, we can actually fix this problem here too. If inner does not equal outer, well, we just said that they equal right here. Can't we fix that? Yeah, we can. We can simply add 1 to this and check the next one. As I'm sure many of you saw in my demonstration already, we can just get rid of that. Get rid of the matching curly brace. Shift tab these back out. Keep our tabs nice and clean. Clean code is readable code. All right, this is beginning to look a little bit better. So now we don't have to do that extra check. We've forced that inner and outer won't be equal. This is good news. Okay, let's go ahead and run this again. Let's see if we got rid of any. We still have 8. Okay, let's go ahead, let's copy this again since we know it works. We might need to do some drastic things. Let's go ahead and turn off this one since we know it works. And let's dive a little bit deeper. Let's see what we can really start to do. Well, string this outer is running every single time we go in the inner loop. That doesn't really need to happen every time we go in the inner loop. That can happen every time we go in the outer loop. Now that's only going to run a couple times. Now that's not going to affect our loop counter number, but it will affect our program efficiency. What are some other things that we can do? Well, we're doing another if statement. Can we grab this if statement out? Well, yes, we can. And actually, this is really bad coding right here. This is a big no-no. No duplicates is a Boolean. Booleans don't need to be checked against Booleans. This is the same thing. You've just wasted time by having a double equals. So we have if no duplicates. Well, we can actually check that in our for loops because our for loops can use compound statements. So we can add no duplicates there. Let me go ahead and squish this down just a little bit so that will fit, hopefully. And we can actually do this same check up here as well. So now even our outer loop will double check that there's no duplicates, and it won't run our outer loop if there's too many, or if the duplicate is found. It will immediately, or not immediately, but it'll quickly kick us out. And we'll tab that out. I'm going to go ahead and zoom out just a little bit, just so that all my code fits in line. Hopefully that's still readable for you. Okay, so we've got things down quite a bit. Let's take a look at this. Let's run it now. We still have a loop counter at 8, so it doesn't seem like we've made a big jump in this number. But let's go back, and part of the reason why I left the previous code was that I wanted to be able to go back and show you what these two different sets of algorithms do when we look at larger sets. So let's go back to the first one, a kind of ugly version here. Let's run it, and let's do the entire alphabet. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. No duplicates found, and our loop counter is 650. Okay, that seems like a lot. With only 26 characters, we did a loop counter of 650. Okay, let's turn off this one. Remember that number, 650. Let's turn on this one, and let's run it again. Let's see what number we get now. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Oops, I typed duplicates in there. Somewhere in there, I typed a duplicate. I don't know where it is. Okay, so it found a duplicate, and it only ran 286 times. Now, if I had typed this properly, I know the number is 325. Half as many cycles to go through, and even the cycles are even shorter because we move this string outer outside of the inside loop to make it run even faster. Doesn't sound like a whole huge difference, but it's big, twice as fast. If you can make a program run twice as fast in computer science, you are making a huge stride. Imagine if we had to do something like this that checked not a couple of characters, maybe 20 or 30 characters, but maybe checked 1,000,000 characters. Or if you were working at a company like Facebook that has billions or trillions of pieces of data, if you were able to run a piece of software twice as fast on a data set that large, you're now making a huge difference. And you're thinking, when would I ever use data sets that are that big? Graphics. If you are writing a video game, if you are doing anything that has to do with something that prints to the screen, not just printing characters, but actually draws and gives each pixel its color value, you are doing thousands, millions, billions of calculations per second. If you can make it twice as fast by simply changing a few variables in your loops, you're making huge strides. So algorithm efficiency is an important part of writing programs for this class and for the AP exam. Recognizing which algorithm is going to be more effective is an important skill. Okay, hopefully this was a fun exercise for you. I will see you guys in the next lesson.